Okay, so first thing we're going to talk about is how do we find extrema on a closed interval. So here's what you're going to do. First of all, what we need to do is we need to find the critical numbers on the interval. And it's important that you do not use any critical numbers outside of the given interval. And then you're going to evaluate the function at each critical number. And then after that, you're going to evaluate the function at the two endpoints of the interval. And then put it all together. The least of those three values, or however many there are, the least of those values is actually going to be your absolute minimum, and the largest is going to be your absolute maximum. Okay, let's take a look. Here I have a function 5 minus 2x squared. Now, all we want to do is find the largest and smallest value for this function over the interval from -2 to 3. So what we're going to do is we're going to first find the derivative. So the derivative of this function is minus 4x. So x equals 0 is a critical number, and 0 does fall within the interval. So I'm going to evaluate the function at the critical number, x equals 0. That's the only critical number I got. So if I evaluate this function at x equals 0, I get f of 0 is 5. So I know the y value is 5 at that critical number. Now then I want to evaluate the function at the two endpoints, -2 and 3. So we're going to plug -2 into the function, and when we do that we get 5 minus 2 times 4, so that's 5 minus 8, which is -3. And then the other endpoint is +3, so we're going to evaluate it at +3, so we have 5 minus 2 times 9, so that's 5 minus 18, which is -13. So these three numbers, -13, -3, and 5, are the only values that can be extreme values over that interval. So the smallest of those three numbers is going to be the absolute minimum, and the largest is going to be the absolute maximum. Well, the smallest is -13, so that's your absolute minimum over that closed interval, and the largest is 5, so that's your absolute maximum. Alright, let's look at another one. Okay, this time I'm going to look at the function y equals x cubed minus 12x over the interval from 0 to 4. So I'm going to take the derivative. The derivative is 3x squared minus 12, but if I factor a 3 out, I get 3 times x squared minus 4. Now if you set this equal to 0 and solve it, you'll get two critical numbers, x equal 2 and -2. But here's the catch. -2 is not in the given interval. The given interval is 0 to 4. So -2 is not in there. So we're going to throw that one out. So we're just going to check what the value of the function is at +2. So I'm going to evaluate the function at 2. So plug 2 in and I get 8 minus 24, which is -16. And then I also have to check it at the two endpoints. So if I plug 0 into the function, I'm going to get 0. So f of 0 is 0. And if I plug 4 in, I get 4 cubed minus 48. So that's going to be 16. So these are the three candidates for extreme values on that closed interval. So look for the largest one, 16, that's your absolute max. And look for the smallest one, -16, that's your absolute minimum over that interval from 0 to 4. Okay, let's take a look at a trig function. Here I have f of x equals 1/2 x minus sine x, and I want to find the absolute extrema from 0 to pi. So the first thing I'm going to do is I'm going to find the derivative of this. Well, the derivative of this is 1/2 minus cosine x. So I'm going to set that equal to 0. So set 1/2 minus cosine x equal to 0. And if you move the minus cosine x to the other side, you basically get the equation cosine x equals 1/2. Well, cosine x equals 1/2 at a lot of different values, but on the interval from 0 to pi, it only equals 1/2 at pi over 3. So pi over 3 is the only critical number that falls in this interval 0 to pi. Okay, so now let's evaluate this function at pi over 3. So if I evaluate this function, I get 1/2 times pi over 3 minus sine of pi over 3. Well, that would be 1/2 of pi over 3 is pi over 6. Sine of pi over 3 is square root of 3 over 2. So I went ahead and just plugged this into the calculator, figured out what pi over 6 minus square root of 3 over 2 is, and I got negative 0.342. Now I also have to evaluate the function at the two endpoints. So let's evaluate it at 0. So if I plug 0 in, I get 1/2 of 0 minus sine of 0, and that's just going to be 0. And then I have to also evaluate it at pi. So when I evaluate it at pi, I get 1/2 of pi minus sine of pi. Well, sine of pi is 0 as well, so 1/2 of pi is just pi over 2, which is about 1.7. So I've got three options here: 1.57 pi over 2, or 0, or this number, minus 0.342. So which one of those is the largest? Okay, so 1.57 is the largest. So the absolute maximum is pi over 2. Now the smallest of those three values was this value, pi over 6 minus square root of 3 over 2. Now that's the exact value, but the approximation is negative 0.342. That's the absolute minimum of that function. Now I do need to mention that when we look at trig functions, we generally study trig functions over a specific interval due to their nature, because many trig functions tend to repeat a cycle over and over. For example, the previous problem, this problem actually had critical numbers at pi over 3, 5 pi over 3, 9 pi over 3, etc. But pi over 3 was the only critical number in the given interval. Now down here is another example that you can practice on. Take this function, find its derivative, and find the critical numbers of that derivative. Now I got a critical number of negative 2/3, and when I plug negative 2/3 in, I got the value, a minimum of negative 0.385, and then you can evaluate the function at negative 3/4 and see what you get. And then when I evaluated at the other endpoint at 1, I got square root of 2. So I didn't list what I got at negative 3/4 because that wasn't a maximum or minimum. But you can verify that at negative 3/4 you get a number between these two numbers, so therefore you're not going to get a maximum and minimum at those values. Okay, so that pretty much completes this section on absolute extrema. Now we want to talk about increasing, decreasing functions in relative extrema pretty soon.